All right, today's lesson is how to use a graphing calculator to find probability distributions. I am using the TI-84 graphing calculator simulator, but all graphing calculators will have something similar. You may have to Google to find exactly where the keys are on your calculator if it looks just a little bit different than the 84. So there's two different distributions we're going to discuss today. The first one is binomial. So our first example reads, 62% of adults have confidence in newspapers. You randomly select 10 adults. Find the probability that the number of adults have confidence in newspapers, as listed below. Since there are only two choices, this is indeed binomial. So, sure my pen is working. So it is binomial. Since it's binomial, the two choices are they have confidence or they don't. So the first thing we need to do is to find P, Q, N, and X. P comes from the 62% that have confidence. So my P value is going to be 0.62. My Q value is a direct relationship. Those are the ones who do not have confidence. So when I subtract it from 1, I get 0.38. My N tells me how many adults we selected. In this case, that would be 10. And my X is all of the possible choices I have in selecting those 10 adults. So with confidence. So I could select and have 0 people that are confident. I could select those 10 adults and find 1 person who is confident, 2 persons, 3, all the way up to 10. So after I figure out all of these values, I'm going to make a quick distribution table to help me solve the rest of my problems. So I'll need a table to find my X values and my P of X's. So my X values, again, are going to be the 0 through 10. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The P of X value is going to be what I find on the calculator. So in order to do this, I'm going to use the feature on my calculator that is binomial. And then I'm going to make sure that I'm using the correct one, which is PDF, P for probability. And when I do that, I have to give it some arguments. And so the argument that I'm going to use is N, P, and then X. That's why we had to find the N, P, and the X. So when I go to the calculator, I'm going to type in this, I'm going to fill in my chart using that information. So I'll go to my calculator. To find the distribution, it's under the blue distribution right here above the vars key. So I'm going to hit second vars. And then I'll have to scroll down until I find binomial. It's actually going to be letters A and B. I want binomial PDF again. C stands for cumulative numbers. We don't want to accumulate anything. We want to just make sure that we're using the probability one. So the PDF. Then it's going to ask me for this information. And again, this is the information that we get directly from our NPQ, and X values. So we're going to start with the fact that our trials have 10 trials or 10 adults. My P value is 0.62. My X value now is going to cycle between 0 and 10. So I'll start with 0, hit enter. Then it's blinking. Do you want to paste it? Yes, I do. So hit enter. And I will see this string. And again, that's my binomial X, N, P, X. Hit enter. And now I get this strange looking number. Now be careful because this is in scientific notation. The e to the -5 says I'm actually moving this decimal point 5 places to the left, in which case when I do that, I will end up with the number 0.000628. Then I'm going to do the exact same thing to find all the remaining 10 items. To do this, if you haven't learned the shortcut of second enter, after I clear it, second enter is going to put the exact same line from above. So I'll tab over, hit 1, and now it's my binomial with 10 adults, 0.62%, and this time 1 person chosen. And now I have 0.001, so that'll be the next value, 0.001. Go back to the calculator, hit second enter again. I'll tab backwards, changing that 1 to a 2, hit enter, and I now get 0.008 when I round it. Be sure to round. In this case, I'm rounding to 3 decimal places. Hit second enter, changing the 2 to a 3, hit enter, and I get 0.327 or 0.033. Then I'll just continue using the calculator to find the remaining 10 values in a similar fashion. And when I get that, I have the following. So for 4, I get 0.093. For 5, I get 0.183. For 6, I get 0.249. For 7, I would get 0.232. For 8, I would get 0.142. For 9, I get 0.051. And for 10, I get 0.008. So we'll stop right there because it's always a good idea to check and make sure that the sum equals 1 and that all of these probabilities are between 0 and 1 because it's a probability distribution. And indeed, yes, all of my P of X values are between 0 and 1. If I add these up, so go back to your calculator and I add them up, 0.000628 plus 0.001 3 hit enter, and yes, indeed, they are a little bit more than 1, and that's not surprising since we rounded throughout the 3 decimal places. Had we never rounded, we should have come up with exactly 1, but it's 0.000628, which is checked and fine for verification purposes. Also in your chart, you'll notice that these numbers go from smaller to larger in the middle values, and then back down to smaller values, which should also make sense because the probability that you get those middle selections is more common than if you get 0 people having confidence or all 10 people having confidence. So once we've done that, now we can go straight to answering the questions. Question number A says, find the probability that exactly 5 adults were confident. Exactly 5 adults says simply, go to the line number 5, and here's my answer. So the probability of 5 is exactly 0.18. And I'm done. Probability of at least 6 says that I'm going to have to do some addition now. At least 6 means it could be 6 could be 7 people, it could be 8, it could be 9, it could be 10. So I'm going to add all the probabilities together. So 0.249 for 6 plus 0.232 for 7, 0.142 for 8, 0.051 for 9, and last the 0.008. If I add all of those up using my calculator, I end up with 0.682. So again, what that means is out of the 10 adults, I'm going to randomly select what is the probability that at least 6 of those adults have confidence in the newspaper. And 0.682% of the time, or 68.2% of the time, we would find that those adults, that we would find at least 6 adults. The probability is. It's not quite a percentage, but it's similar. What is the probability that we have less than 4 adults? So again, less than 4 would be 0 through 3. So if I add those numbers up, 0 through 3, I would have the 0.00006. I can stop there because of the significant digits, 0.001, 0.008, 0.033, add those up, and I end up with 0.04206, which we can round then to 0.042. So again, the probability that I would select out of those 10, the probability that less than 4 people would have confidence. So we line them up, and less than 4 people are confident would be 0.4042. Probability between 5 and 7 inclusively would be the probability of 5 people plus the probability of 6 plus the probability of 7. So in this case, we would have 0.183 plus 0.249 plus 0.232, all coming from my chart. So this time it would be 5, 6, and 7 added together from the chart. Add them up, and I indeed get 0.664. So once you make this probability distribution table, that will help answer all of your questions quite nicely. It helps with the arithmetic very easily. The biggest thing is making sure you're hitting the correct button on your calculator. So again, it's binomial. Make sure you hit PDF, and then you're going to need your n value, which is the number that you are selecting. The p value is your probability of a success, and your x value is each one of your choices for the number of adults who qualify your statement. After this recording, I've left a second problem for you to try, so you can go in and work through this one and make sure that you can use your calculator correctly, make sure you understand the buttons, and can get the correct answers. The answers are listed in the back or on the end of this page. All right. So then the second one that we're going to talk about is standard normal probabilities. So this one is different. It's different in the way the problem reads. So it says, in a recent year with total scores for a standardized test are normally distributed. So again, there is your key word, normally distributed. The mean is 500. The standard deviation is 10.3. So that's a little different wording, but that's all we need in this case. So first thing I need to know is my mu is 500 and my standard deviation is 10.3. The function that I'm going to use this time is no longer binomial because this one is now standard normal. So I'm going to use the function normal. It is a CDF this time because we want it to accumulate. I'm going to get accumulated values. I'm going to need a lower bound an upper bound, my mu, and my standard deviation. So lower and upper is your smaller to your larger in that range. So I don't need a chart this time. This one's a little easier. I don't need the chart. It says that I want the probability that I randomly select a person who took this test and I have a score of less than 488. They scored less than 488. So we want the probability that X is less than, I'm not sure what's happening. There we go. X is less than 488. So let's think about that for just a second. If X is less than 488, it could be 487, it could be 480, it could be 470. The point being, when we look at this problem, I have no lower bound. The 488 is actually an upper bound. In fact, I'm not even sure the lowest score you could get on this test. The lowest score may be 300, the lowest score may be 200, the lowest score may be 450. We just don't know. So there is no lower bound. When there is no lower bound, we are going to use negative, because we want a small number, a large negative number. We want to use a negative 1,000. So we get a large negative number to assure that we don't touch up near the boundary of this test. And since we don't know that boundary, negative 10,000 will be just fine. By standards, some calculators default, and we'll see in just a minute how the default button looks on the TI-84. So we're going to go in then, and we're going to hit normal. Again, we want CDF this time. Since there's no lower bound, we're going to use negative 10,000. The upper bound will be 488. My mean was 500. My standard deviation was 10.3. So on my calculator, I can't use the back button because I'm not looking for binomial this time. So if I clear this out, and I hit second distribution again, second bars, gives me my distributions. Number 1 and number 2 both are normal. We want number 2 because it is a cumulative one. And again, here's what we talked about by default. That's negative 1 times 99, 10 to the 99th power. So that means move that decimal point from in front of the 1, from behind the 1, 99 places. That's a lot of decimal points. We don't need that. You can leave it if the default makes you happy, but if you want to change it to negative 10,000, you can also do that. Choice is yours. The upper value in this case, we said, was 488. My mean is 500. My standard deviation was 10.3. Hit enter so we can paste this in there. And again, here is my normal CDF, lower bound, upper bound, so smallest value, largest value, the mean, and the standard deviation. Hit enter, and I get 0.121999. 0.121999. .12199. Rounding that, we would get 0.122. And that's it. So number B says we want a test score more than 500. So what's the probability that my test score is greater than 522? So this time again, it could be 522, could be 523, could be 524, could be 600, could be 700, could be 800. We just don't know. So this time, again, there is no upper bound. And if there's no upper bound, we're going to use, this time, positive 10,000. It gets us far enough away from what the boundary would be. And if we did that, we would have normal, CDF, the lower bound. So remember, it's always smallest to largest. So the smallest number this time would be 522. The largest number would be 10,000. Standard deviation is still 500. And we have 10.3 for the mean is 500, 10.3 is the standard deviation. Using your calculator, I use the back button this time. I'm going to have to go back pretty far because I have a lot of things to change, but I can just arrow back. And instead of negative 1,000, this time we have 522. The comma is above the 7 key. 10,000 for my others. You can delete any unnecessary numbers, any extra. Hit enter, and now we get 0.01634. 0.01634, which if we rounded that would be 0.016. And you can see on the calculator how this negative 1,000 or 10,000 doesn't make a lot of difference. If I hit enter and I go back, hit the back button, and let's change that to negative 1,000. So we'll delete one of them. So now instead of my upper bound being 10,000, it's only 1,000. You can see the very little change. In fact, no change in this case. So that's why 10,000 is a pretty good number to use at that point. Okay. So for C, it says that we want the probability that my test score is between 498 inclusively and 511. So 498 to 511. That's going to make this one a lower bound, this one an upper bound. And my calculator work will be normal, CDF, lower bound, 498, upper bound, 511, 500 is still my mean, standard deviation of 10.3, going directly to the calculator. Now this time it might be a lot to do the back button. You don't have to do the back button at all. If you went back to second bars, hit number 2. Now my lower bound, we said, was 498. Hit enter. My upper bound was 511. Standard deviation is still 500, mean is still 500, standard deviation 10.3. Hit paste. Hit enter, and I have 0.434211. 0.434211. If we rounded that, it would be 0.434. So again, interpretation for this says that I'm looking at a group of students who took a standardized test. The mean of that test was 500. The standard deviation was 10.3. I randomly select a person from this group. And the chances that when I randomly select that person, the probability that I'm going to find a person whose test score is between 498 and 511 would be 0.434. So about 43% of the time, I would find a person whose score was between 498 and 511. That's a rough interpretation. Okay. I also have another problem for you to try that is standard normal, so you can look at it and work with your calculator. And then at the end of the document, I have the answers to all 4 problems so that you can verify for sure that you are using your calculator and getting the correct answer. So try your calculator and see how much simpler it is now to find these probabilities. A little bit of work setting up the binomial, but still not much when we consider how easy it should be to get these answers. And then that's it for today. Thank you.